we can do the same type of calculations with melting and freezing. Again, this is showing us that the energy needed to go from a solid to a liquid, in this case, I would need to add 6.02 kilojoules for every mole of water that's going to melt, and for every mole of water that's going to freeze, the water must lose. That's why the negative sign is there. Lose 6.02 kilojoules per mole. This is called the heat of fusion, or the delta H of fusion, right? So the delta H FUS is that energy that needs to go from solid to liquid and vice versa. In the same way that we did these problems with boiling and vaporizing, we can do this with freezing. So it says how much energy is required to melt 25 grams of ice. So 25.0 grams of solid water. The data table tells me that these are all in terms of moles of water. So the first thing I need to do is convert to moles of water. And then the table tells me that 1 mole of water will require 6.03 kilojoules of energy to melt. And to 3 significant figures, that rounds to 8.37 kilojoules. That's how much energy I would need to add in order to melt that much ice into liquid water. And the next question is asking about the amount of ice in grams that when it melts will absorb 237 kilojoules. So that's the number I start with, 237 kilojoules of energy or heat. The delta H of fusion of water is 6.03 kilojoules of energy for every 1 mole of water. And then, of course, I know 1 mole of water is 18.016 grams of water. And to 3 significant figures, that tells me that I would be able to melt 708 grams of water if that ice was able to absorb 237 kilojoules of heat. So this next one, see if you can try this one on your own. Calculate the amount of heat absorbed when 15.5 grams of ice melts at 0 degrees Celsius. So pause and try this problem. So what you would do is you would take 15.5 grams of water. Of course, we need to get that into moles. So 1 mole of water is 18.016 grams of water. And one mole of water has a delta H of fusion of 6.03 kilojoules of energy. So how much energy will need to be absorbed by the water when it melts? That comes out to 3 significant figures, 5.19 kilojoules of energy. And this is another one of those questions that we're going to be using the delta H to find in the formula MC delta T. So this is a 5.6 gram cube of ice is placed in 195 grams of water. So think about, here's my water, here's the ice cube that I put in it. If the heat absorbed from melting the ice comes only from the water, right? In order for this ice to melt, it's going to have to absorb energy from the liquid water. So the ice cube is going to go from solid to liquid, and it's going to absorb energy, which means that the liquid water is going to have to lose energy. And losing energy is going to make it colder. And the question is asking, what is the final temperature? Or it says, first of all, what is the temperature change of the water? And then we can find the final temperature of the water. So the first thing I need to figure out is when this 5.6 grams of water in the ice cube melts, how much energy does it absorb? I know 1 mole of water will absorb 18.016 grams, and 1 mole of water will absorb 6.02 kilojoules of energy as it melts. So the melting ice cube will absorb 1.87 kilojoules of energy. That's how much is absorbed by the ice cube. And now that must mean that 1.87 kilojoules of energy is going to be lost by the water. Okay, 1.87 kilojoules. I know that 1 kilojoule is 1,000 joules. So I can just take that number, and it is 18. It actually comes out to 71 joules. So that's how much energy the water is going to lose. So 1871 joules. I converted it over to joules because I know the specific heat of water is 4.184 joules per gram degree Celsius. Solving for delta T, of course, my joules will cancel and my grams will cancel. The change in the temperature of the water will come out to be 2.24 degrees Celsius. That's what the question is asking. What is the temperature change in the water? But if it starts out at 25 degrees Celsius and it loses 2.24 degrees Celsius, afterwards it will be 22.7 or 23 degrees Celsius. This is how ice works. How does ice cool the water? Because it absorbs the energy from the water, lowering the temperature of the water.